welcome everybody. Thank you for coming. I'm Marshal Willet. I'm representing Team 10, Athens' own custom sealer. Along with me for the ride is Garrett Black, Ben Oros, and Joel Zimmer. So our customer is Constantine Faller under a company called Athens' own. They're located just outside of Athens. Athens' own is a company that produces and sells various food products. Currently, some of those products can't be sealed correctly or efficiently, so they are in need of a product that can create a custom width and custom length size bag and have it heat sealed on these two sides. And also something about Athens' own is that they are also in the market for creating more jobs and being sustainable and resourceful as possible. So some of our specifications that we're trying to make sure that we hit are definitely that we are able to create these custom width and length size bags. And then also we want to make sure that these bags are sealed on at least two sides. And then also they have to have an efficient heat seal for FDA approval, and that's food regulations. And then also we're trying to be resourceful and compact as possible for Athens' own. So going over these phase 2 summary, I'm going to give you a picture representation of kind of how we started and got to where we've got to our final design. This all kind of starts where, from the left, we did some patent researching. Through patent research, we kind of found a lot of mechanisms that are already on the market that can cut and heat seal plastic stock roll. So then, once we determined that, this kind of helped this idea generate what our product would be like in our final design. We kind of go through the current process of how they can't efficiently heat seal some of these products, and then our new design process that we hope our product is capable of performing. And then on the right, you'll see that we actually did some more chart analysis and principles that we looked at for idea generation that were very helpful in learning what aspects we could use in our final design. From here, we kind of had a rough draft sketches of our individual concept designs, and these are all on the left, and they were presented by Ben Oros in our poster presentation earlier this semester. Keep in mind, most of these concepts are motor powered, since that's what we kind of learned from our patent researching. So from here, we used a variety of grading tools to help us narrow down to our final concept design that we were going to continue with in senior design. So here is actually a representation of comparing our conceptual designs to all of our specification requirements for our customer. And then we also did another rating tool on an individual level to kind of look at the feasibility of all the aspects that we had in our own designs, rated by our other team members. This was kind of helpful for our collaboration as a team to work more together. So from all these different rating tools that we used, we ended up having a second draft phase of our individual concept designs, and then we could narrow that down to our final conceptual design that was more of a hybrid of our concept design 3 and design 4. This implemented an actual single cut and heat seal mechanism, which is the most efficient in the product that we were looking for. And it also was the most cost effective, it was very compact, and it was the most resourceful that we could find from our individual concept designs. So like engineers, we ended up hitting a roadblock, and this typically will happen in your lifetime. So we ended up finding a discrepancy on the online website for the heat sealing and cutting mechanism. They actually don't offer the cutting mechanism down the center as an option anymore. So this kind of made us have to go back a step and figure out how to solve this problem. So our reaction was to do two different routes. Our first route was to kind of just go back one step, look at some idea generation, and find out how to incorporate a cutting mechanism into our final conceptual design. Our other route, which was good, was we ended up going back even a further step, looking at the project as a whole, and we tried to simplify our components and aspects of our design to see if we could find a design that still fulfilled the success criteria given to us by our customer. So here are our key decisions made in phase 2. We ended up determining that all the components that are involved in our original concept were a little bit too much complex, and that it would require too much time to finish by March of 2015. This is involved in the testing requirements that we would have to do, in the heat sealing mechanism, and the cutting mechanism, and in the actual process of the feed rollers as well. And then after that, we did discover an alternative solution that was much more simplified and resourceful, which is good for Athens' own, that still fulfilled all the customer specifications for the project. So here's a look at our new alternative design that we're going to continue with into phase 3 and the rest of senior design. As you can see, this is kind of just a standard table, but it has 3 main components on top. It starts out with a supported stock roll for their actual tubular plastic stock, and then it has an impulse heat sealer and an adjustable cutting mechanism. The user will be able to pull the tubular stock roll past the heat sealing mechanism, that's the stapler in the middle, and then that will be able to be pulled to length and then cut and sealed. And then necessarily from that cut and seal, you'll have a 4-sided sealed bag where they'll be able to put it at the origin at the bottom left of the table and use the adjustable cutting mechanism to create custom widths for the bags, which will produce 2-sided and 3-sided sealed bags, which exceeds our customer specs. The key factors in why we did decide to go with our alternative route, other than our original route, is kind of shown here. Our original route was more motor power, and our alternative route was labor intensive. But by doing this, you actually reduce a ton of risk for injury and failure in your design by the user making sure that it's correct, the correct motions. And then highlighted in green, I wanted to kind of announce that the expected time and the cost was very important for our project. The expected time to be built for this project actually decreases in half, and so does the cost. So that makes it much more resourceful and enough time to complete our project and make upgrades or modifications to make it more efficient as well. So after this, us finishing up phase 2 with the alternative design approach, we ended up going into a little bit of analysis of a couple analyses of our burritos for a couple different aspects that are very important, like build complexity, failure, and your cost. So for the build complexity, what we're actually going to be using our time spent in the construction phase is mainly going to be primarily made up of our adjustable cutting mechanism and our table with the marked etches. And as you see in the red line, that's almost about 70% equivalent for the entire project and time management for build complexity. We also did a cost analysis, and this involves about 6 different aspects. And what we already agreed upon and we figured out through research is that the impulse heat sealer, the adjustable cutting mechanism, and the etch table that we'll have to create will make up most of the budget in our project. We also did a little bit of failure, designing for safety. So we looked at all the dangers in our project for the user and any individual that's next to it. We wanted to make sure that this is as safe as possible. So I'll indicate that the exposed blade on the cutting mechanism should have a cover, is what we're creating, so that there's no area for the actual user to be cut or any individual around it. We also looked at the accessibility. This is more about kind of the safety issue of the stock roll being placed onto the supported shaft. We need to make sure that that is ergonomic and where it's kind of at a level where the person putting it on there doesn't get injured by lifting it, because it is pretty hefty, around 50 to 75 pounds. And then we also want to make sure that anything that's wearable has replaceable items for that as well, in case anything goes out on the project. What we will have to continue looking at is our design analysis. There's a couple aspects that were the bulk of the budget, especially the table and the adjustable cutting mechanism. We're looking to simplify those as much as possible through this analysis to make sure that we can reduce the cost for being resourceful for Athens' own. So here's where we kind of came to our budget. We'll start from the left and kind of go down to the bottom right, where you'll see our final budget. It's 827. It all started with having a very big system for a 40-inch impulse heat sealer so that it was applicable for any kind of stock roll. After talking to our customer, we kind of did narrow this down a lot to a final amount of $827, which would suffice for the efficiency of our product. So currently we're also working on assigning team members to the construction phase. To help for this, we did make a flow chart to assign any task to any individual or possibly the entire team to accomplish as soon as possible. And then we also did create a project time plan, and this is going to help us finish things that are more important with deadlines and due dates, and also assign members here so that there's a better plan for our project. So currently we are starting to purchase some of these items for testing, such as the impulse heat sealer, the staple heat sealer, and then we're also going to be on track to finish phase 3 by the end of the semester. And we also have thumbs up from our Dr. Kramer, our mentors, and our customer Constantine Fowler. Is there any questions?
The heat seal.